Welcome everyone to our podcast today. Today we're thrilled to introduce Tanay. He's a data scientist. He's a data science graduate student at the University of Bath and also a Kaggle Grandmaster in notebooks. He has a rich background that includes his stints at NVIDIA, and he also brings a wealth of knowledge and experience in machine learning to the table. He's particularly interested in ML explainability with transformer-based models. Besides his academic and professional background, Tanay also actively contributes to open source ML projects, like Hugging Face transformers, for example. So let's get straight into the pod. So I guess the best place to start off with is how did you get here? What's your background? How did you get started in AI? What's your journey been like? What have your key milestones in your career been like?
Right. First of all, thanks a lot for having me. So I started doing machine learning all the way back in 2018 when I was starting my undergrad in computer science. So I saw this video by, I think, Seth Bling. It was a very famous Minecraft YouTuber. So I saw this video of him teaching a Mario agent to play itself using a genetic algorithm and neural network, and that sort of got me interested in all of these things. And yeah, then after that point, I was just like, it's basically a long journey of experimenting different things, trying this out, trying that out. Some worked, some didn't. But yeah, that's basically how I started. I believe it was the COVID, like the start of COVID-19, so basically early 2020, when I started doing Kaggle, because everyone was a lot freer at that point. They were just at their home, so Kaggle seemed like a really nice place to upskill and to learn about things. And yeah, that's where my career trajectory started.
I saw actually that, like in Minecraft, someone created a neural network using just redstone. And I'm looking at like, this is one of the most incredible ways to apply it. And I learn it from like a young person's perspective, right? Is you can actually implement using redstone neural networks. So it's interesting. That's how you got led into the ML space.
Actually, there's a side note. So I would argue that implementing a neural net in Minecraft is way harder than implementing it on a computer, because you need to like basically implement a little computer. As far as because I used to play a lot of Minecraft, so even implementing like a logic gate is quite complex, considerably complex, and you have to like build logic gates on top. But yeah, I do get what you're saying. It is certainly a good a step in the right direction for young minds to be intrigued by something like that inside a game. So, they're not very intimidated by like programming languages and IDEs and like monitors.
And you're learning from first principles, and it's completely gamified, the entire approach, right? And they're already kind of used to the environment you're in. So, I mean, that's potentially something to explore in the future is actually teaching people through video games, right? That's a really fascinating way to bring that.
Yeah, definitely. That's like entire CS degree in one game, because you go from basic electronics all the way to neural networks.
How do you go from that background to being at a stage where you can contribute to open source projects? And what was your motivation for doing that as well?
So my real motivation, so when I was working at NVIDIA as an intern, this is around like July, August of 2021, and I was working on this product called Rapids, which is like their framework for doing the basic machine learning, the classical machine learning, but on GPUs. So it's like taking scikit-learn and stuff like that just runs on CPUs and doing that on GPU, which was a really nice product. And it was all open source. It still is. So I was what I really liked doing was I was seeing their source code and a lot of functions that are in sklearn that are very simple, and they're there for everyone. They weren't present in Rapids. So other than after my job, I was also thinking of, adding them to Rapids. And it kind of added, like, it gave me a very unique opportunity because everyone has used scikit-learn. And I got the exposure to the Rapid side of things. So I was in the position to do that. So I tried a couple things. Didn't work because ultimately it turned out that you needed a lot of low-level GPU program, like CUDA knowledge to do that. But that sort of icebreaker really like got me started. So I was really interested in NLP, and that's when I started so once my internship got over, I got a free time. I started like, okay, let's contribute to transformers, because that was like still is the go-to NLP framework. So that's where it started.
No, I think there's so many people who try and break into coding, and machine learning now especially, right? And they kind of stop at the first hurdle, especially with Python. There's a lot of, when you start learning Python, there's a lot of errors you're getting that just make zero sense if you're trying to implement linear algebra, like linear regression model or something quite simple, right? You're just getting errors from just even downloading Python. I mean, how did you get around that? How did you get over that first hurdle that some people fail at?
I think so. There are like two versions of this answer. One is pre-ChatGPT version, and the one is post-ChatGPT version. The pre-ChatGPT version would be perseverance. So I've seen a lot of people. Unfortunately, when they see error, they get scared by it, and that's how they sort of eventually decide, okay, programming is not for them. But it's actually like a peak. Once you're past that, you no matter how foreign that error seems, you will still make sense of it. So I think the more straight up solution is to persevere. If you have an error, just Google it. That's very simple, and you will get an answer. I think with tools like ChatGPT, and also, for example, Google has added the Gemini in Google Colab. So if you face an error, and I think you have to be in like a beta program or something like that, but if you have an error in one of your Colab cells, there's a little button now which says explain with Gemini. And I was at first I was really critical of that. I was skeptical that would it work or not, but it surprisingly works. Even for frameworks even like for closed source frameworks, it gives very good sort of direction to look into.
They used to have a button that says Google this. Instead, they used to have a button that just goes straight to Google with your error. But yeah.
No, so what it does is it opens a little sidebar, and it's basically the Gemini window, and you can chat with it.
Yeah, it's pretty cool. That's pretty cool. I haven't had to play around with that, but here's another question. And do you think people learning to code with ChatGPT, because they don't? So when I learned to code before ChatGPT, and because I would go online and search Stack Overflow, search through docs, I would actually learn quite a bit more. So do you think there's a difference in the quality of coders that come out of the post ChatGPT era, or do you think it doesn't make a difference?
I think there's definitely a difference. Again, it depends a lot on the personal ability and how much you're passionate about what you're doing. But in general, I think pre-ChatGPT people who learned coding by themselves were much more resilient, like people like us in our sort of basic understanding, because it's the same thing as Google and pre-Google people. Before Google, if you wanted to find something from a book, you would go to the library, read 3 books, and then you'll find that. But in the process, you will have surrounding knowledge from those 3 books. So Google sort of replaced that. When we wanted answers, we could get a very exact, near exact solution. So I think ChatGPT is like a step further in that direction, in the sense that it's now giving you a very exact answer. So your knowledge is sort of like very, very, not limited, but like very streamlined into exactly what you're learning. That does save a lot of time, but for people who are starting, who have a lot of time, I think it's not really a great idea for them, because they should like explore by themselves, get stuck, because it teaches you both how to get unstuck by yourself, and it also teaches you how, like, a few other things, surrounding things that you would otherwise not know if you just ask the answer.
It's incredible how many times I would go down a random rabbit hole, and that turned out to be useful like a year and a half later. I was like, oh, crap, I actually know this because of this, this one thread I went down one time. So yeah, I mean, you're losing a lot of that ability to generalize across different tasks because you're so streamlined in your focus, right?
Yep. And plus, like, there's like a funny story. A couple months ago, and I don't use these tools, by the way. I don't use for coding. When Copilot came around before ChatGPT, I think it was like 2022, I believe. I used it for a lot of time, and in 3 or 4 months, I realized my programming skills dropped down significantly, and then so I just removed it and haven't installed it ever since. It is hard at times, but I think it keeps you in check. So anyway, I was searching through Stack Overflow a couple months ago about a certain way to filter elements really quickly in Python in a list or a data structure, and I saw this answer, the other answer that was doing something else. That approach wasn't relevant to me, but I read it anyways, and that answer had there was a bug that was coming in with that approach. But some weeks later after that, I faced a similar bug. So if I hadn't read that answer, which wasn't relevant, by the way, I would have never understood that bug, probably wasted a couple more hours trying to fix this, which at that point I was like, oh, yeah, I see this one. I have seen this one. So it's just one of the many examples.
I mean, a devil's advocate would say these are only things which are useful as long as we still need to code. As soon as we get things like ASI, who knows? Maybe we might not need to code as much anyway. But
I think there will be. I think coding will still be around. Yeah, because I think for these models to train for longer durations, you need a lot of human data. If you keep training AI models on AI generated data, they, at least from what I've seen, I may be very wrong, but their quality sort of starts decreasing because you're training it on AI generated data. So I think there will be coders around. I think that will still never go away.
on the topic of open source, by the way, we are both quite interested in hearing your opinion on the landscape of open source and closed source in terms of AI and in particular LLMs. So, you want to tell us a little bit about that?
Sure. So, I mean, currently, it's just the way I see things is in the open source space, we have the major contributor, the players are Meta, obviously, and Microsoft has been releasing a couple really good models, low-level models too. And yeah, basically, and then there's like community and smaller startups that are fine-tuning those models, releasing the other ones. But Meta is the main player in sort of open source LLMs. And in closed source, we have OpenAI, Anthropic, and they have their own standard models. Also, Google, but I'm really not convinced by Gemini so far. Maybe the opinion will change at some point, but I think it's Claude 3 and GPT-4 are the two really serious competitors right now.
So I was just going to ask, what's the motivation for companies like Meta to actually create open source models? Why would they do that?
So I think that's a very business decision from even from the outside of it. But my theory is that the reason they are doing this is twofold. First, to take away, because they somehow see OpenAI or Google and Microsoft in their also in their own different ways. They see these companies as a competition when it comes to AI models, and by training AI models and releasing them for free to the public, they basically make the market more fair by taking away the much needed competition from their competitors. So, for example, I believe Llama 3 400 billion parameter variant is still training, but when it is released, I have my hopes high. Maybe it will actually surpass GPT-4 in capability if it's ever allowed to be open weights like the 70 billion variant. But in a case like that, you just take away the monopoly from OpenAI or Claude or any other big provider. So I think that's one of them, and the other one is I think, and that's a very niche theory. I'm not even sure if that is their goal, but by doing something like that, if they make AI models so good, open source AI models so good and so perfect at generating good natural language, eventually people will use that sort of model to, write stuff, post stuff, generate images on their own meta platforms. So in some sense, they're making good models because I think this will enhance their own platforms down the line. So by making it open source, not only can people use it, modify it, retrain it for different purposes, but they also take the competition away, and they also make their platform better.
Can we practically just define what open source means in this case? Is it open weights, so just files of numbers essentially, or are we talking about the actual code itself that goes into training the models, or both?
So I think the code as well as the weights are so it's not really about if the code and the weights are not available, because they are otherwise. If you don't release the weights and you sort of if you don't release the code, you just release the weights. That sort of is like a little counterintuitive. You can't load the weights, and vice versa. So these models are both open weights, and the code is also open, but it depends on their use cases. So open source is, I think, more liberal in terms of use cases, what you can do. I'm not really on the policy side of things, but I think Meta and also Mistral's open weights, so their licenses are a little different. You can't do all sorts of things with them. But yeah, so it's really about how you can use them, not about what they're open sourcing.
And is the data open as well? Are they easily accessible data sets, the ones that you train in these models?
I think some of them have. Some of them have. They use publicly available datasets plus some other scraping of their own. I think it was Alan AI who released their Olmo model back in February, and they, I think, released the weights. They released the model code. They released like even the training code of how you can do it in the repository, and I think they also released the data. So that was like one of the rare examples of true complete open source.
Okay, I'm just going to play devil's advocate for you then. Should these models be open sourced? Does it allow people to basically misuse these models? And looking forward in the future, as these models get a lot better, a lot more capable, should they continue to be open sourced? What are your opinions on that?
Okay, so my opinion on this, I think a lot of people are just like very strongly divided on this topic. But the stand I take is, and I like to use this analogy, which is that AI models, large language models, are like nuclear technology. People compare them with nuclear weapons. I would like to just compare them with the basic nuclear technology. So you can use that for making nuclear reactors and make clean energy, or you can use that for making nuclear bombs and blow up cities. So does that mean nuclear energy is wrong? Obviously not. It depends on the use case, right? But can it be misused? Obviously, yes.
But we don't have any private companies hoarding a bunch of nuclear weapons, do we? That's all done by the government. It's nationalized. So should AI be nationalized?
Well, that's because but the reason behind that is how it started. The reason behind that is when nuclear weapons started, because the government has control. So I think it's very specific, but I get your point. You're asking whether it should be nationalized or not. I don't really agree. I think it should be something that everyone. There is obviously one key factor here, which is that you need specific, very expensive setups to train. So in that sense, maybe nationalizing it will take away the monopoly from certain big companies who just have a lot of money. But I still think that it should be open. It should be like kept open, because and I don't think nationalizing will actually change anything, because unlike nuclear weapons, you can obviously anytime open a VS Code IDE and code your own GPT model, right? So you don't need like specific enriched uranium to do that.
Looking forward, when you need an insane amount of electricity to actually train these models and to run inference, I'm speaking like let's say 10 years down the line when we need that amount. I think nationalizing is the only way we're going to get access to that amount of electricity. Is just the way that I was thinking about it. And also, let's say for example, these models are capable of let's say coming up with new bioweapons, for example. Do we want that in the hands of every single individual, or should that then be fenced off at that point?
So to answer your first question, with the current state of AI models, yes, after a certain point, only like really huge corporations will be able to handle them. But again, this is where AI research is catching up. So maybe there are a low resource consuming alternative of AI models, or we find a better way to train them, in the sense that anyone can train them. Not anyone, but even like medium-sized individual companies can train them. Coming to your second question, I think so. I do understand your point, but it comes down to this. So you take any sort of hostile national state actor or non-state actor, but the one that has resources, they still have enough resources to train a model, right, by themselves. And it's all public knowledge. It's already public knowledge. And once it's public knowledge, it will be, right? It's open source, so it's always going to be there. So I think they can use it either way. Fencing off some very critical, like groundbreaking research might actually be one of the things. But I think in pursuit of actual research and development, making it open source is much better, because then most people have access. See, it all comes down to how many minds can work on that. Different minds have different ways of approaching things, different ways of pushing a certain knowledge forwards. So it again comes down to the whole nuclear energy versus nuclear weapon argument.
It's interesting that you mentioned basically keeping some of these algorithmic advancements a secret. I don't. So I was basically reading Situational Awareness by Leopold Aschenbrenner yesterday, and he actually touches on this exact topic. He was saying To keep our advantage in the West compared to the East, one thing that AI startups in particular, lack is secrecy and security. For example, these algorithmic advances are what keep us ahead of the East, and we don't have the security in place to stop things like state-level espionage from the East. Do you have any comments on things like that? Is that something that AI startups need to consider?
I honestly don't think I'm probably in the best spot to answer that question, but I think my opinion would still be that I would still like to stick with the more minds means more research and more ideas approach. Um, the thing is, if you see a model right now, the one that is released, the one whose information is well known, for any model like Claude 3 or GPT-4, for instance, they are not that different in terms, at least considering that we know, like the public knowledge of them is somewhat close to what they actually are. In that case, they're not much different from the original models. They have some architectural changes. So to say that, to fence off a model like that and then expect a competitor country or a non-state actor to not come up with something like that is rather funny, because the knowledge is already out there, and you, with enough research funding of any, I'm not naming countries here, but of any country that any other country considers hostile, they can obviously come to that. But yes, there is some point in fencing off very like niche, very groundbreaking research. But I don't think fencing off LLMs is going to do much. Like, it's not going to do much good.
So do you think at the moment the advantage, because right now obviously the private sector is further ahead than open source when it comes to the quality of their models. Do you think the advantage for these companies lie in their ability to aggregate just a bunch of data and create the sophisticated data pipelines behind that, or is it in their ability to actually like perform any of the algorithmic advances to improve the models or the architectural decisions that are needed to improve the models?
I think a little bit of both, but it's mostly on the data side. Yes, they have some really bright minds to work on the algorithmic side of things, but and again, this I might be biased and limited based on my knowledge, because things are moving so fast these days. It's like really impossible to keep up with everything. But I think if you go with like basic GPT-3, GPT-4 architecture, there aren't many completely groundbreaking, like changing algorithmic changes. So it's definitely the data and how many GPUs you throw at it to make it better.
Interesting that you mentioned data, by the way, because something else that Leopold touches on in his series as well is something he calls the data wall. He claims that we're actually using up all the available internet data for training, or that we've got already.
Yeah, so I mean, yeah, that is actually very true. I haven't went into complete specific, like I haven't dived into complete specifics of how much data like the recent models are consuming, but I think it's a pretty common knowledge that it's mostly all of the scrapable internet data that you can scrape legally that has been used. I think the next frontier would be like something like what OpenAI Sora was trying to do, and then Mira Murati was like really confused, which is like, are you using YouTube data? And she was like, I don't know what to answer. So I think that's something that can be done for video or generative image models. For text, I think we have a lot of text data in like books that are like in physical copy in libraries across the world, or in digital libraries that are like fenced off. So to scan them and to use them, I think we'll still have, there's a little bit more to squeeze, not too much, but a little bit more.
Yeah. Are there any interesting like data quality filtering mechanisms that you're aware of, that if you have, you know, a massive corpus of like data from the web, you know, the kind of mechanisms you could put in place to actually improve the data quality of your data sets? Are there any you could touch on?
I'm not particularly aware of any like standard set procedures, but I think it's a bunch of like it is made up of a small set or a rather large set of little techniques that based on platforms. So for example, if you're scraping Reddit data, rather than scraping all Reddit comments and posts, you would scrape any with more than 3 upvotes. That would consider some sort of quality of the data, or it depends on the subreddit. And same goes with YouTube. I think on Reddit you have a negative downvote thing. So if something is negative downvoted, chances are that it's either A, very profane, or B, not matching with the subreddit's sort of theme, or it's factually incorrect. So if you have those central assumptions, then you can make these sort of quasi rules of how to scrape the data. But I'm not actually aware of any sort of rules, because my work is mostly in training the models. So the first step I take when I'm starting off is taking a good completely cleaned off data set, like find web data set or Wikipedia data set, and I start from there. So I'm basically skipping the basic steps of cleaning the data and gathering the data part.
Which lies on the data engineer, and our life suck because of it. But I'm glad that you guys are making use of it.
Yeah.
Oh no, that's like a typical thing that happens in a lot of these companies. You join as a data scientist, and then they're like, "Yeah, we just got this data. We haven't cleaned any of it. That's up to you." And like, you don't need a data scientist, you need a data engineer. But yeah, that's me complaining, I guess. Yeah, whilst we're on the topic of your work, do you want to tell us a little bit about what you're doing for your master's in terms of phase transitions in language?
Yeah, so for my master's thesis, basically, and obviously it's still ongoing. It has really started yet, so I can't go into much details. But like on a broader scale, I'm basically my thesis will be about generating scaling laws for live language models, and then hopefully we'll be able to see phase transitions by training smaller models. Obviously, we don't have a lot of big computational resources, so I'll be training, and I'm still training smaller language models and generating
I'm
laws.
just going to interrupt you there. Do you mind explaining what phase transition actually is? Because I didn't know until you mentioned it last time either.
Right. So, okay. So phase transition is basically like this sudden abrupt change in a model's performance, after which a large language model, or a language model more broadly, starts showing emergent abilities like reasoning and stuff like that. So the actual textbook definition basically says that if you take a smaller model and you see its performance, right, and you extrapolate its performance for many epochs or data sizes, emergent ability you can't extrapolate. Like that's something that suddenly happens with a phase transition abruptly. Like that's something that's not predictable. I mean, obviously you can predict it once we have studied enough phase transitions. Okay, for this size of model, it happens around this at this range. But for just any small model that you just have right now, you can't just predict a phase transition or emergent ability. So basically, it's when model in very layman terms, it's basically when a model starts developing abilities that are not present in the smaller models.
Once you brought it up, I saw some of the graphs on Anthropic's paper. It was just a sudden dip. I think it was in the loss. But yeah, it's really cool stuff. But what exactly is the significance of phase transition, and how does it impact things that actually matter to data scientists, like model performance, alignment, interpretability, safety, things like that? If you want to touch on that a little bit.
So it's very active area of research, and we still don't know a lot about phase transitions. Everyone has their own little different way of explanation. Oh, okay, this is not really something interesting. That's just explainable behavior, etc. But phase transitions' significance is that when you their existence implies that there are certain thresholds, and that it's in some sense quantifiable with enough research and enough advancements. So, for example, I'm not entirely sure how it will go in the terms of safety, because that's not exactly my topic of research. But if you're training a model to sort of develop mathematical abilities, and you see phase transitions, and you see similar phase transitions for a family of models with different large or smaller architectural changes, you sort of see that. So now and that's where the scaling laws come into. So now with that scaling laws, and for your viewers who don't exactly know what scaling laws are, it's basically a law that determines how much data a model needs to train to a certain level of performance. So that basically is how much should you scale it, right? So scaling laws, given with the ability of knowing when the phase transitions, that sort of combined ability gives you a very clear picture of how much data do you need, and like how many phase transitions will you see before the model starts learning an ability. It's a really, among other things, it's a really nice sort of rule book, or not a rule book, but like a rough set of rules that will give you the amount of resources you should put in, the amount of GPUs you should buy, because that sort of thing you have to preserve if you're going for a very big project, right? Reserve. So like H100s, you just can't like spin up 500 of them suddenly. And so I think that's where this is the main significance. Apart from also understanding why do models perform the way they perform, why do they develop the emergent abilities they develop, because we still really don't know.
So if you're a company who's trying to invest in AI, it actually adds a little bit of predictability to the fiscal side of things. Insofar as you only need to invest this much, you will know at this milestone that your model will be performing at this level. Okay, that makes a lot of sense. And I think what's interesting, I wanted to understand how you guys are studying this, right? Because an analogy that really stuck with me is the difference between behavioral psychology and cognitive neuroscience when it comes to actually evaluating models and understanding how they work. So behavioral psychology is through the lens of actually just assuming the model is a black box, much like we assume our brain to be a black box 60, 70 years ago, and understanding like the cause-effect relationships from the patterns we're seeing in the model's output. And then cognitive neuroscience is actually going from a bottom-up approach where we're understanding deeply how certain mechanisms work, and then we're kind of deducing our way upwards and deciphering the entire kind of behavior of the model. So in studying phase transition, is that more similar to the cognitive neuroscience approach, or is it more significant, similar to the behavioral psychology approach, like as in you're studying the patterns?
So we're basically studying the patterns. It's a pattern-up approach, and that's also where interpretability comes in, because fundamentally neural networks are black boxes. We don't know how we have some general perception idea of how they learn, but we don't have an exact theory, a learning theory of how neural networks learn. And it seems that with different architectural changes, like if you take a ResNet image classifier versus an LLM that has attention, they may have completely different ways of learning things. Obviously, another area of research. So the point is that the way we do this, and I think the way most of the researchers do this, is by training many different models with many different steps. So, for example, you take a model, you fix its parameters, and you fix the number of epochs, and then you train it on 100,000 tokens, 1,000,000 tokens, 1,000,000,000 tokens, 10 billion tokens, and then you sort of see how it performs, because you basically fix a few parameters and you change one, and then you do the same thing for all parameters. So it's a lot of training. And a lot of plotting, and that's when you sort of infer, okay, these are the patterns that are emerging.
Nice. I think once you know and understand how these patterns emerge, that's very important for safety. Because if we can predict how some of these future models would actually, develop these emergent behaviors, then maybe we can understand and avoid dangerous behavior as well. But yeah, you mentioned.
Yep. And
sorry, go on.
Even from like a national security sort of standard point of view, with even a somewhat defined rule book of model behavior of how it will train, it could come in handy with the country doing the research. For example, if country A has good researchers and they have a learning theory of how models scale, they know when their competitors exactly when they will reach. So for example, like we see, right, we see in the news all the time that this XYZ country will be enriching uranium at this point 3 months later, and because we can infer it because we have actual laws. So something like that. And I think that's why governments would be a lot interested in funding this sort of research. So they have a concrete theory of how these models grow. And so they can, because they think everything from a very competitive standpoint, from the national security standpoint, and from also like not being left behind.
I really like the idea of having a playbook of how these things evolve. That's a really nice way of putting it. Thank you. Also, earlier you mentioned interpretability, so I think we might as well touch on that. What exactly is mechanistic interpretability, and why is it important?
So basically, as I said earlier, the way neural networks learn is you just give them a lot of data, and they basically figure out some sort of rule and algorithm that we don't know, that's the black box part, to solve a problem. And they don't exactly solve the problem. They do a very approximate solving of the problem because it's a lot of linear algebra and probability. So interpretability and mechanistic interpretability at large is basically an attempt to go back in the opposite direction, to take the output, to take the model's performance, and also know the data. And then we try to make sense of what exactly did the model learn. So we're trying to make the black box less black in the sense that we're trying to see exactly what the model learned, what was the why it take a certain decision, what features it extracted, and so on and so forth.
Yeah, I think from talking with companies, the lack of interpretability and understanding as to why a model made a decision is a major bottleneck and preventing them from actually applying AI in their technology. How would that practically play out, right? I mean, if you can just give me hunches toward that you might have, how would that play out in terms of, if you're actually using a model, it will explain to you why it made a decision, or are you able to like look at some sort of dashboard somewhere and see, the different concepts that are used to make the decision?
So I would like to mention 2 points here. One of them is the more recent one, which is what Google did. I think Google released a tool very recently, which allows you to see sort of the tokens a large language model is paying more attention to and less attention to, or something like that, especially for LLMs. So that's something like that which shows it visually. But I would like to take, for the second instance, I would like to take an old example, which is GradCam and these things. So these are like the old CNN based tricks where you can visualize what features of an image the CNN is actually paying attention to. And I think that's a good way to sort of think about this, because then you see, okay, the model is looking here. So I'll take a simple example. Let's say you have a large LLM, and let's say 10 years down the line, we actually have a good tool which ensures like 95% positive results, like accurate results for interpretability. So then you can open the sort of mythical AI dashboard and you see, okay, these specific layers or these specific attention heads in, like, let's say layer 8th or 9th, they pay more attention to, and they act in favor of generating profane statements, and that's a medical chatbot or like a normal chatbot. So then you can just prune those heads, and that's I'm talking in a very mythical sense, but I'm trying to like pass on the general theme of it, is that if you find out where the problem is and you have a way to reliably and responsibly remove that part without changing the model performance, then interpretability changes the whole game. Because there was this funny thing that happened I think a month ago, when Tata, no, it was not Tata, it was some another company. I think it was Hyundai or something. They integrated an OpenAI powered platform for their chatbot on the website. And it was really nice because it's way better than all the normal chatbots we use now, except that people with some basic jailbreak prompting were breaking that chatbot on the website and asking to generate Python code or poetry, which is just basically supposed to be a car detail bot and nothing more. So with things like that, and with open source models, and that's where they all sort of come in, with open source models and things like that, every company can have access to a state-of-the-art model. They can see exactly, with a small research team, obviously, they can see where these models are making decisions using interpretability, and they can then remove or tune those things out. So the model will be aligned. So as you can see, like the interpretability, open source, and alignment, they all sort of come together at the last step.
Oh, I love that. It's very similar to Anthropic's paper, which I only got around to reading like last week. They were mentioning things like polysemanticity. So apparently each of these nodes actually fires for multiple features. So they were trying to break down each of those using sparse autoencoder to individual interpretable features for each of them. And then they were able to see when a particular response gets made, which of those features was fired for that particular response. And they had some pretty cool examples. Like they identified one which was an interpretable feature for the Golden Gate Bridge. And they're able to steer the model by using these interpretable features. So if you basically amplify that to, let's say, quite a bit more than it normally is, then the model itself will start to generate responses believing that it actually is the Golden Gate Bridge itself. It was quite funny to see that. So yeah, it's a very interesting area of research that I see right now. How do you think this will impact alignment?
I think this would change the entire game for alignment. I think with a solid tool or methodology for interpretability, alignment will not be the same again, because it would, I would like to believe it will make things much simpler, and that's what logic dictates as well. Maybe it will give light to more complex problems that await, because again, these are black boxes. But I think end of the day, it's a good news for alignment. And I think we need alignment a lot in large language models, because when you sort of train them on the entire internet of data, you have a lot of conversations so I'm not sure if any big open source firm has trained a large model and released it without any sort of alignment or reinforcement learning from human feedback tuning. But if they do, it will be surprisingly like some people will definitely be convinced that it's like this model is conscious based on how nicely it talks to you. But that's where they do alignment. They sort of make it sound less like a real human being, more like a model. So there's all these things that say as a large language model trained by OpenAI, XYZ, that's all alignment. That's
Sure. I mean, just to clarify for the audience, polysemanticity is my and please come in with a more technical definition if you can. My explanation is you can't appropriate a single node to a concept, to a single concept. So it's actually very hard to make it interpretable. It only makes sense when you take the entire network into account. Is that right, or how would you expand upon that?
yeah. So that's in the right direction. So basically, and when I told you about this, if we find the certain attention layer is doing the wrong thing, we can remove that. There was a big asterisk there that I didn't mention, which was polysemanticity, which sort of not allow it doesn't allow us to do that. But yeah, essentially, polysemanticity is many different layers, or not layers, but many different nodes or parts of a network. They all, which are seemingly not common, they all fire together to give rise to a single feature, right? And that is the sort of problem, because if many seemingly unrelated nodes are firing to make a specific feature, output feature, then it's very hard for us to prove which part causes what. So yeah, that's basically the definition is correct. Yes, but it might not be on the topic level. It might be on a very smaller level. So it can be like three different attention heads in parallel could learn in conjunction could learn how I don't know, the grammar works in a sentence in English data, right? So stuff like that.
So could you just really quickly explain a feature? So my understanding is like the atomic unit of knowledge within large language models. Is that going the right direction as well as to what a feature is, as opposed to a concept?
So again, it depends on how the model learns it, because we give it a lot of data. We ask it to predict the next token. So you might have a very different concept of an atomic unit, as you say, like the smallest unit that the model understands. A small GPT-2 model may have a very small, very different concept to a large model. Obviously, you can extrapolate that type of thing, but it depends. So I don't think I can really point a finger to exactly what, because then again the problem comes with interpretability. We don't understand what it sees, but we do know that different sort of, for example, different attention heads in an attention layer, they all learn different things. Like one of them may learn semantic ordering, one of them may learn grammar, one of them may learn gender in a gendered language, for instance.
Nice. Just bringing it back to alignment, you mentioned RLHF. Longer term, like let's say next 10 years, how do you think that is actually going to play a part in how we align these models? Do you think RLHF is scalable to when we get much more capable models, or do you think there's something else that we need to basically develop?
I think there are, I'm not sure if they're like drop-in replacements, but I think there are better techniques than RLHF that are like developed. I think it was, so that's where the reinforcement learning research that's been going on for the past couple of years, or maybe like a few decades, comes into the play. So I think, yes, we do need better technologies, and better ways to sort of align them with the human values or the values we expect. They also need to be, I think one of the topics that are less talked about is they need to be equally hardware compliant, in the sense that they need to be equally parallelizable, efficient on the hardware, because then it becomes a very engineering problem. Because on research side of things, it's all good and fine and nice and shiny with green grass, but when you actually do that on a hardware side of things, you want to do that very efficiently. So I definitely think we need way better techniques to do alignment for much less resources, which are efficient, that is. Yeah.
Nice. Yeah, we also mentioned in the last conversation we had, the initial conversation that we had, the whole problem with Gemini, how they released a model which wasn't actually properly tested, let's say, for all its possible failure modes. And I've been reading around. Leopold as well recommends things like adversarial testing for things like this, to basically test all the failure modes of certain models. Is there anything else that you can think of to make these models safer in production, apart from alignment? Maybe if you can expand on testing and any other things that you can think of to make failures a lot less catastrophic, I guess.
I think it has less to do with tech, I believe, and it has more to do with the policy of the company, or not the company specifically, but of the team, or what they're actually aiming for. one of the things that from a very naive perspective, I would say is just give the model and give it to a blind group of 70 or 80 people and ask them to go wild with it. And I think that would be able to identify a couple problems more than any like team itself would do. Because if you remember, the problems in Gemini image generation, they came after they released it to the general public. So if you take like a smaller sample set of the public, you sample from the public with equally of all demographics and all different backgrounds, and they test it. I think that can be done. But I haven't read much about the actual testing techniques. That's sort of not exactly my area of expertise, but yeah.
Yeah, I think that's definitely a concern. If the companies are training these models are injecting their biases into the model, it gets pretty scary. But also fundamentally, what Shad was touching on with RLHF was that method only works insofar as humans are more intelligent in the model and can actually understand the model's output, right? So when we get to a point where the model becomes superhuman in terms of cognitive abilities, it's like having a toddler trying to evaluate a PhD student. It makes no sense because it has no understanding as to what the output of the model even means. It'll be too complex. Obviously, I'm not expecting you to solve the problem like on this podcast call. It's something that everyone is focusing on in the super alignment team. Or I mean, it's dead now, but there was a super alignment team that was focused on that at OpenAI. But are there any other methods to align the output of models with either business cases or desired outputs other than RLHF, which might not have the same downsides, like insofar as the human actually has to understand the output?
So I think there are different techniques other than RLHF. So for example, there's like PPO, proximal policy optimization, and stuff like that. And this is all coming from, by the way, the reinforcement learning playbook. So if you just open certain Barto or something like that, and you have a lot of techniques that you can adapt to this sort of agent framework. But I think so what you said initially was that at that point, it's like a toddler trying to evaluate a PhD. I would like to add a point that if it ever does happen, if the model ever gets so intelligent, I don't think we will be the ones aligning them. I think it would be the other way around probably, because yeah, there would be, if they're intelligent than us, I think. But I don't really think personally, that's my personal belief, that I don't think a large language model can do a creative work or an analytical critical reasoning like a human can do. I don't think that's possible in the current type of LLMs we have.
But ever?
With the current type of LLMs, maybe not for a long time, maybe not for a couple more years, maybe a decade or so, because we are kind of reaching an upper limit, not just in terms of data, but also in terms of compute, because now it's like millions upon millions of dollars to train a model. It's not very easy anymore.
I mean, let's take the conversation a bit more speculative then. Let's say constraints on compute are lifted, constraints on the data wall are lifted, and now we've gotten ASI, artificial superintelligence. How do you protect catastrophic failure modes from something that is a lot smarter than humans?
I think that's I'm not even sure if that's like a very active area of thought, but I believe it would be. I would like to take a few pages from the Marvel playbook. Is that don't let it near the nuke codes and don't let it near the passwords. So that would be like the first from the Terminator playbook. But on a serious note, I think I personally don't think that's ever going to happen. To be very honest, I don't like, my belief for the future is an advanced human civilization on multiple planets or moons. But AI will most likely be a tool that we use like computers, very mainstream, very powerful, but nonetheless subject to humans. Because ultimately you train it on data. It's just the next token predictor. That's my personal belief. So it's just the next. And I think I have taken a lot of inspiration on forming that belief from Jan LeCun, whose tweets I read quite often. So yeah, I believe he thinks that too. But let's just say if it indeed does happen, I think we need a very, very reliant, very powerful kill switch.
Yeah. Air gap servers, that sort of thing. I don't know. I don't know how much I agree with the whole argument that it's just a statistical next token predictor, because it has, complex understandings of the sentences or whatever the concepts that it's thinking of under the hood, like the embedding. So it does have more complex thinking behind it. And we are,
Yeah, that's what we are trying to also learn, right? With the face transitions. That's actually ironic that I'm trying to learn that, but I don't believe in the face transitions being any transitions. That's the duality of man, I guess. But yeah.
Okay, yeah. I mean, look, first, there's some context to this, right? Shav and I are at an event, and we're looking at the applicability of large language models in the public sector. Obviously, the incentives in the public sector is very different from the incentives in the private sector. It has to take into account the needs of many different people and many different cultures and governments, right? And so we were just exploring with the thought, of having like a supermodel that comes out, not to be confused with a woman actual AI model, and we use to make decisions either on the field when it comes to NGOs or other public sector activities. And we were like, would there be a difference between a model and its reasoning capabilities and the way it views the world that's been trained predominantly on Chinese data versus American data? And then we were looking into like collectivistic mindsets, like collectivism in China versus individualism in the US. So would an American model, maybe come to conclusions that have more individualistic kind of traits as opposed to a Chinese model? And so we were really thinking, like, does that actually influence the worldview of the model based on the data it's being trained on? I mean, do you have any opinions on that?
I think definitely. I think from a very intuitive standpoint, it does. It changes everything. I would like to. So there are two things to this. A is like the type of things it generates when you ask it for an advice, and B is the very ground level of how it actually does the reasoning in the model itself. The reasoning part has nothing to do with the type of data. If China was more capitalist than the US, it would still do different reasoning because the language, the Mandarin itself, the way it's written, the script, it's different. I don't know it, unfortunately, so I won't be able to give a very informed opinion on what the model might be doing differently. But I think that's definitely a case when the model will be reasoning about things differently. And I won't be surprised to see that the phase transition for same size model, same amount of data, one in Chinese, one in English, the phase transitions occur at a very different time scale, like during training. I won't be surprised if that's the case. I have never tried that. So I'm speaking from what I think would happen, my basic understanding, as limited as it is. But I think it would definitely make a difference. And in terms of like asking to generate normal text, like, any sort of advice, yeah, you would see a lot of socialism here and there coming in, coming out, because it's been trained on a lot of those texts, right? But that's the case with all sorts of model. If you train one in India, you would see a lot of based on what type of Indian data you train it on, what language. If you train one in Russia or Germany, or example, so that's always there. But when it comes to the language itself, I think it may very well change the way model reasons, but I may be wrong. There may be actually research that disapproves this.
My take on this was that a lot of these models trained off of the scope of the internet would include a mix of languages anyway. So it wouldn't actually be the difference in the reasoning capability of the model itself, but more the way that we align these things, right? So let's say, for example, we get Chinese citizens to align a model. They would, because of the way that they feel or reason about how the outputs of the LLM are, they would align it in a different way to the way that we align things in the West. And I would have argued that the alignment would have actually been a much bigger difference than anything else for these two models. What do you think?
That's actually a very good point. However, I would just like to add another sub point to this, is that I don't think we have a lot in terms of just Chinese versus English example. I don't think we have a lot of example of Chinese because they have much of their internet data closed off to outside. So yes, a lot of our models, the multilingual ones anyways, have been trained on a lot of Mandarin data, mostly from the Hong Kong and Taiwanese part of the places where the internet is still open. I still think that it would be really fun to compare a model that was trained in China. I think there were a couple ones that were being released some months ago versus with an English model of similar level to see how they do in reasoning tasks.
Yeah, we should do that. We should get a model, Shav, and try an American model, the Chinese model.
Yep.
And take like social case studies and see what conclusions it comes to best solve it. And then maybe we could try and detect some sort of biases.
And also,
but I agree with the alignment side of things.
And also like with the eval tests for coding and related tasks. So what I'm really interested in seeing is, does a language play a role in how a human thinks about things, reasons about things, and also does how a model reasons about things. So like at a very basic level of how the language is formed in itself.
Do models even reason that much? So, for example, if you type something into ChatGPT, it generates a response almost immediately, almost without any introspection. I'm assuming you're not doing any sort of chain of thought or anything like that. So I would argue that actually the models that we use naively right now don't do a lot of thinking or reasoning. They're just it's not the same way that a human would do it. A human would read a task, think about how to do it, plan it, come up, do a bit of research, maybe for like a week, and then collate all of this, and then come up with insights that way. I think that's quite a big difference there, no?
So if you take like GPT-4, for instance, and we assume that there's no funny business going behind the back, we just assume that we pass in an input, it goes through the model, and we get the output stat. Then yes, there's no reasoning, because it's just you're just passing a very big matrix to a bunch of matrix multiplication operations, and then it predicts a matrix out. It does predict good words. So I think chain of thought is one of the reasons why it started with the agent system, so they think for themselves. But if you take the simplest example, no, I don't think there's any thinking sort of happening. In fact, in some sense, if you lower down the temperature to absolute zero, you could have almost 99.99% determinism. So when you have determinism, I don't think you really have thinking happening.
So it's literally spitting out exactly what it's seen with no kind of creativity in its output.
No, so you're confusing two things. It does may have creativity. I'm just saying it doesn't probably have determinism. So there's another question I think that we need to ask ourselves, which is that are determinism and creativity are they like mutually exclusive or not? Because and that's where a lot of our questions come down to the philosophical understanding of our own concepts. But I think they are reasoning, but they're just not reasoning in the way we know reasoning works. Okay, that's where the whole interpretability research comes back, because we don't know exactly how it's reasoning about things.
That's true. We just don't know. We just don't know right now.
Yep.
I guess.
Yeah, we don't know right now. Yeah,
that's quite interesting.
Yeah, I mean, this is probably a very fascinating conversation. I mean, look, you touched on the final point there about. I mean, that this is something that is fascinating to me as well. If you put the same person in the same circumstance, right? This is the fundamental idea about determinism. Will it come out with a different output? And you're saying when you lower the temperature to zero, the output's always going to be the same.
Yeah, more or less,
right?
Almost.
And
all
so
the time.
I think,
yeah.
And so you're assessing creativity at this point, like the randomness of the output based on the same situation put in. So the exact same prompt will come out with different outputs based on the temperature, right?
Yes, if you higher up the temperature, basically it's a very mathematical concept, but essentially temperature. If you imagine the probability of the next token as like as a probability curve, then with the zero temperature it would be like a very steep curve. The next token will be the one that has the highest probability. But if you higher up the temperature, make it like 2 or something like that, then the curve will be, instead of being a very sharp curve, it will be like very stretched apart. So you've taken the curve, you stretched it. So now a lot of different tokens are equally likely, or close to being equally likely.
Yeah, one thing I love doing as well is I use ChatGPT when I have like an idea that I'm playing around with. I will take ChatGPT, increase the temperature, and be like, just play around with me and just see where we come to. And it's actually an incredible tool to help you expand your, I wouldn't say understanding, but expand the scope of your ideas.
Yeah.
So that can be applied anywhere. But look, Tanay, you've been absolutely great to chat to. This could go into several hours because obviously we're all passionate about this. We're all looking forward to see what you come out with, and we'll read your research paper when it comes out in 3 months.
Thanks a lot.
But yeah, really appreciate your time, man. Thank you.
Thanks a lot for having me. It was nice chatting with you. Bye-bye.